Hello guys and welcome back to Mathematical Mindset. So right here we have this nice exponential algebra problem and we have to find the value of x. So right here guys, the first thing you want to do is to apply this property that says if we have a minus b all square, this is equals to a square plus b square minus 2ab. So we want to simply apply this property to the left hand side of this equation and we have that a is equals to 3 raised to the power of x and b is equal to 2 raised to the power of x. Hence, we have this to be 3 raised to the power of x all square plus 2 raised to the power of x all square minus 2 multiply 3 raised to the power of x multiply 2 raised to the power of x, and this is equal to 6 raised to the power of x. But 6 raised to the power of x can be expressed as 3 multiply 2 all raised to the power of x. So then we have this to be 3 raised to the power of x all square plus 2 raised to the power of x all square minus 2 multiply 3 raised to the power of x multiply 2 raised to the power of x, and this is equal to 3 multiply 2 all raised to the power of x. But we know that if we have a multiply b all raised to the power of m, this is equal to a raised to the power of m multiply b raised to the power of m. So applying this to the right hand side of this equation, we have this to be 3 raised to the power of x all square plus 2 raised to the power of x all square minus 2 multiply 3 raised to the power of x multiply 2 raised to the power of x, and this is equal to 3 raised to the power of x multiply 2 raised to the power of x. So we want to simply collect like terms. So collecting like terms, we have this to be 3 raised to the power of x all square plus 2 raised to the power of x all square. This is equals to 3 raised to the power of x multiply 2 raised to the power of x plus 2 multiply 3 raised to the power of x multiply 2 raised to the power of x. So we have this to be 3 raised to the power of x all square plus 2 raised to the power of x all square, and this is equal to, we want to simply factor as the common term, and we have 3 raised to the power of x multiply 2 raised to the power of x to be a common term, and if we factor this out we have this to be 1 plus 2 right here. But we know that if we have a square, this is equals to a multiply a, right? So applying this, we have this to be 3 raised to the power of x multiply 3 raised to the power of x plus 2 raised to the power of x multiply 2 raised to the power of x. This is equals to 3 raised to the power of x multiply 2 raised to the power of x into 1 plus 2 is going to give us what? 3. So the next thing we want to do is to simply divide through by 3 raised to the power of x multiply 2 raised to the power of x. So then we have this to be 3 raised to the power of x multiply 3 raised to the power of x divide 3 raised to the power of x multiply 2 raised to the power of x plus 2 raised to the power of x multiply 2 raised to the power of x divide 3 raised to the power of x multiply 2 raised to the power of x, and this is equal to 3 raised to the power of x multiply 2 raised to the power of x multiply 3 divide 3 raised to the power of x multiply 2 raised to the power of x. So from here we have that this is going to cancel out this, so we have 3 raised to the power of x divide 2 raised to the power of x plus this is going to cancel out this, so we have 2 raised to the power of x divide 3 raised to the power of x, and this is equal to this will cancel out this and this will cancel out this, so we have this to be equal to what? 3. So from here we're going to say suppose a is equals to 3 raised to the power of x divide 2 raised to the power of x, then we have 1 over a to be equal to 2 raised to the power of x divide 3 raised to the power of x. So hence, we can easily rewrite this expression to be a plus 1 over a, which is equals to what? 3. So we have this, if you look for the LCM, we have a, and this is over 1. So 1 into a is a, so we have a multiply a plus a divide a, well, 1 times 1 is 1, and this is equals to 3. So we have a multiply a is a square plus 1 over a, and this is equals to 3. So if we cross multiply, we have a square plus 1 is equals to 3 multiply a. So we have a square plus 1 is equals to what? 3a. So rearrange and set this equation to 0. We have this to be a square plus 1 minus 3a, and this is equals to 0. Rearranging this properly, we have a square minus 3a plus 1, and this is equals to 0. So we want to solve this quadratic equation by making use of the quadratic formula that states that a is equals to minus b plus minus the square root of b square minus 4ac divide what? 2a, where a is equals to 1, b is equals to minus 3, and c is equals to 1. So we have a is equals to minus into minus 3 plus minus the square root of b square, which is minus 3 all square, minus 4 multiply a, which is 1, multiply c, which is 1, divide 2 multiply a, which is 1. So a is equals to minus times minus is plus, so we have this to be 3 plus minus the square root of minus 3 square is 9, Minus 4 multiply 1 is going to give us minus 4. Divide 2 multiply 1 is 2. So A is equals to 3 plus minus the square root of 9 minus 4 is 5 over what? 2. So from here we have that A is equal to 3 plus the root of 5 over 2, and A is equals to 3 minus the root of 5 over 2. But we want to simply recall, the right here we said suppose A is equals to 3 raised to the power of x divide 2 raised to the power of x. So we want to recall this right here. So we have that A is equals to 3 raised to the power of x divide 2 raised to the power of x. Same thing here, A is equal to 3 raised to the power of x divided 2 raised to the power of x. So I'm going to solve for this part first before solving for the next part. So from this part, we have this to be 3 raised to the power of x divided 2 raised to the power of x is equal to 3 plus the root of 5 divide 2. But we know that if we have a raised to the power of x divide b raised to the power of x, this is equals to a over b all raised to the power of x. So applying this, we have 3 over 2 all raised to the power of x is equal to 3 plus the root of 5 divided 2. So right here, we want to simply take the log of both sides. So taking the log of both sides, we have this to be log 3 over 2 all raised to the power of x is equal to log 3 plus the root of 5 divided 2. But from the property of logarithm, if we have log a raised to the power of b, this is equals to b log a. So applying this, we have this to be x multiply log 3 over 2 is equal to what? Log 3 plus the root of 5 divided 2. So divide both sides by log 3 over 2 to isolate x right here. So dividing this right here, we have this to cancel out this. So we have that x is equals to log 3 plus the root of 5 over 2 divide log 3 over 2. So applying this property that says if we have log a divide log b, this is equals to log a base b. So we want to apply this formula right here. So we have this to be x is equal to log 3 plus the root of 5 over 2 base 3 over 2. So this becomes the first value of x right here. So let's simply solve for the other part right here. So solving for the other part, we have this to be 3 raised to the power of x divided 2 raised to the power of x is equals to 3 minus the root of 5 over 2. So applying this property, we have this to be 3 over 2 all raised to the power of x is equals to 3 minus the root of 5 over 2. So from here, we want to simply take the log of both sides. So taking the log of both sides, we have this to be log 3 over 2 all raised to the power of x is equal to log 3 minus the root of 5 divided 2 right here. So we have this to be, if we apply this property that says log a raised to the power of b, this is equals to b log a. So applying this property, so we have this to be x multiply log 3 over 2. This is equals to log 3 minus the root of 5 divided 2 right here. So divide both sides by log 3 over 2 right here to isolate x. So if we do this right here, we have this to cancel out this. So we have that x is equal to log 3 minus the root of 5 over 2 divide log 3 over 2. So the next thing we want to do is to apply this property that says if we have log a divide log b, this is equals to log a base b. So applying this property, we have this to be x is equal to log 3 minus the root of 5 over 2 base 3 over 2. So we have this right here to be the second value of x. So we have the values of x right here. Hence, the values of x are given us. So we have the values of x. X is equals to log 3 plus the root of 5 over 2 base 3 over 2, and x is equals to log 3 minus the root of 5 over 2 base 3 over 2. So these are the values of x. So guys, this is how you can solve this nice exponential algebra problem right here. So with this guys, I'm going to see you in the next video.